Okay, so let's have a look at the Leaving Certificate Higher Level Maths Paper 1 for 2019, question 3. So we want to first of all just factorize this expression here, so that should be reasonably straightforward. So that's 3xy minus 9x plus 4y minus 12. So this is a group of 4 and we want to just factorize it. So the way we do this is we group them in pairs. So let's take the first two. We have a 3xy minus 9x. Well, if you look at the numbers, the highest common factor is 3. We have an xy and an x, so let's take out the x here. So we see that 3x times y will give me 3xy. We need to put in a minus here to give us a minus here. Plus times minus is minus. 3 times 3 will give us 9. And we have 3x times minus 3 will give me minus 9x. Here we have a 4 and a 12, so let's take out plus 4. Let's see what happens. We have a y here but no letters here. So we need to multiply the plus 4 by y to give me plus 4y. Plus times minus will give me minus. And we need to multiply this 4 by a 3 here to give us 12. So plus 4 times minus 3 will give me minus 12. So just to finish this off, we can factorize again by taking out the y minus 3, because you can see we've got a y minus 3 here and y minus 3 here. So we're going to be left with 3x plus 4. So that's the remaining two terms here. So that's it for part A, fairly straightforward. Now in part B it says use your answer to part A or otherwise to solve g of x is equal to 0, and we're given a g of x here function. So our g of x here is 3x log x minus 9x plus 4 times log x, and then we've got a minus 12. Now you should probably have noticed that this is exactly the same as what we had up here, except that instead of the y here they've substituted in a log x. So really we have this factorized up here if we need to do that. Now what we want to do here is solve this for g of x equal to 0. So in other words, we want to let this equal to 0 here, which means we have it factorized already, we have it done up here. Instead of the y we have a log x. So it's log x minus 3, that's this part up here, and then we've got a 3x plus 4, we don't have to change that. It's already, we don't have any y's in there, so we don't have to do anything with it. So what we've ended up with here is log x minus 3 times 3x plus 4 is equal to 0. That means one of these must be 0, so we'd say log x minus 3 is equal to 0, or 3x plus 4 is equal to 0. That will give us log x is equal to 3, or here we'd end up with 3x is equal to minus 4, and finally down here we would end up with, well, what we can do here is this is log x to the base e, so we would say e to the power of 3 is equal to x. We just convert it to index notation. Over here we end up with x is equal to minus 4 over 3. So there are two solutions. Now you just got to be a little bit careful here. We can see that e to the power of 3 is a positive number. E is positive when we're raising it to the power of 3, so it's going to be positive, so that's fine. This here is a negative number, and we can see in our original function here we've got a log of x. Now if you try to find the log of minus 4 over 3 on your calculator, you'll get an error. So this solution here is not going to work for us. So this is actually our answer here. So our answer is actually x is equal to e to the power of 3, and we're going to just ignore this one here. Okay, so that's really it. You could convert this if you wanted to, but it seems to kind of go on forever. It's 20.08553692 and so on and so on. But this is our actual answer here. Okay, so let's move on to the next section here, which is part C. Now in this particular case we've got to differentiate g, and we've got to substitute in e into our differentiated function. So let's work through that. So we know that g of x is 3x log x, 3x log x. We've got a minus 9x. Then we have a plus 4 log x, plus 4 log x. And then finally we've got a minus 12 out here. Let me just double check that to be sure. So we've got 3x log x minus 9x plus 4 log x minus 12. So 3x log x minus 9x plus 4 log x minus 12. That's fine. Okay. So let's differentiate this then. So we have g dash x is going to be equal to, so we've got to differentiate all of this. So if we look at this part here, this is a product, so we've got to use the product rule here. We've got a function of x times a function of x. 3x is a function of x, log x is a function of x, they're multiplied, so we've got to use the product rule. So it's u dv dx plus v du dx. That's in your maths tables. So it's u, it's going to be u dv dx plus v du dx. That's what we're using here. So u is going to be u is our 3x and v is our log x. So it's u, which is 3x. I'm going to multiply that by the differential of log of x. If you differentiate log of x, you get 1 over x. So that's u dv dx plus v, which is log x, and we want to multiply that by du dx. So if we differentiate 3x, we'll get 3. Okay, so that's the first term differentiated. Let's look at the second one then. Minus 9x, if we differentiate that, we just get minus 9. Over here we have 4 log x, so that's going to be plus 4 times, if we differentiate a log of x, we get 1 over x, so 4 times 1 over x, so it's just 4 over x. And if we differentiate minus 12, we'll get 0. So let's just tidy this up a little bit. Here we got 3x on the top, and we have an x on the bottom here. These will cancel, or they'll divide to give you 1, so we'll just end up with 3 here. Over here we'll end up with 3 log x. 3 log x. We've got a minus 9, and we've got a plus 4 over x. Okay, so let's see, from that we've got, we'll just write it out, we've got 3 log x, so put that first. We've got a 3 minus, well, we put the other x, the 4 over x next. Then we've got 3 minus 9, which is minus 6. Okay, so this is what we get when we differentiate g of x. Now we want g dash e, so in other words we want to substitute in e for x. So in other words we get 3 log e plus 4 over e minus 6. So if we do this, let's see what we get here. We get, well, log e to the base e is just 1, so we're just going to get 3 here. 4 over e here, and we've got a minus 6. So look, 3 minus 6 is minus 3 plus 4 over e, and I think I have this worked out already. Let me just check here. It's 3 minus 4 over e is minus 1.53, and this is to 2 decimal places. 2 decimal places. I think that's what they asked for up here, isn't it? Corrected 2 decimal places. So that's it. I don't think there's another part to this question, so that's it for this question.